Good morning. I'd like to take just a couple of moments to tell you about, I think, a real breakthrough that we've had in how we can design and actually build our notebooks. Now, I'd like to start by really giving you a sense of context, by giving you a sense of the sorts of problems and challenges and issues that really preoccupy us when we're designing this class of product. Now, to do that, I'd like to show you how we actually build our current 15-inch MacBook Pro. That's a product that some of you will be familiar with. Now, one of the most significant challenges when you're designing a product that is as thin and as light as a MacBook Pro is actually making it strong, making it robust, making it torsionally rigid. Now, I think you'd be surprised to know that the aluminum enclosure that you can actually see makes a relatively small contribution to the product's overall structure. Now, the structure's primarily derived from this. This is an internal frame. It's actually made from, it's a magnesium die casting. It's made of multiple parts that are then assembled into the bottom case. And the bottom case is a very thin aluminum pressing. Now, it's this combination, this composite, that starts to create a strong system, a robust system. Now, the palm rest, which is also made from a thin piece of aluminum, requires the same sort of internal structure. So there's a series of stiffening plates and internal structural frames that are actually welded to the underside of the palm rest. And you can see that these internal frames also provide the support for the trackpad and for the keyboard. And then finally, we add this plastic gasket, and that helps us control the reveal or the junction between the palm rest and the bottom case. Now, even though the current 15-inch MacBook Pro is absolutely best in class in terms of its size and weight, we have been looking for a new way of solving these problems. And for years, we've been looking for a better way of building a notebook. And we think we found it. We had a really significant breakthrough that culminated in the design and manufacture of this product. This is our MacBook Air. There is no way that you could build a product that is as thin, that's as light, and importantly, that's as strong and robust as the MacBook Air, given the architecture that I just described. So rather than start with a very thin piece of aluminum and then add multiple parts of internal structure, we discovered that if we started with a thick piece of aluminum and actually removed material to create mechanical features in the structure, we discovered we could make a much lighter, but importantly, much stronger part. And that's exactly how we make the palm rest for the MacBook Air. So we make the palm rest actually from this solid piece of aluminum. This is an aluminum extrusion that's been blanked and then goes through multiple stages that include laser scanning, laser piercing, and then CNC machining. That's computer numerically controlled machining. Now, I'm just going to show you a few of those stages. And we start off by creating the locating features. Now, these are the features that are constant with the part, that follow it all the way through the process. Now, we then go through a very noisy stage, which we call rough cutting, where we're removing large amounts of material very quickly. We create the holes for the keycaps, and then machine the perimeter. And at this stage, we also create some of the mechanical features, like some of the screw bosses. And then towards the end, we finally bead blast the part and then anodize it. Now, one of the fantastic things about aluminium is how recyclable it is. So that at each of these distinct stages, we're continually collecting the material and cleaning it and then recycling it. So we started with a solid slab of aluminium, high-grade aluminium, that weighed over 2.5 pounds. And we end with this remarkably precise part that now only weighs 1/4 pound. And it's not only incredibly light, it's very, very strong. That one part, just that single part, forms the structure for the MacBook Air. Now, it really is this highly precise aluminium unibody enclosure that made this product possible. So this new way of building a notebook that we pioneered here, I mean, obviously has a relevance beyond the MacBook Air. And we've been working super hard on trying to design some new unibody enclosures for some new notebooks. Thank you.